Howdy, my name's Pat Gunn, and this is a test for an educational video on, well, actually a series of educational videos on how to program. And the reason that it's a test is that the computer that I was going to use to actually record and edit the videos died a few days ago. But as a test, I'm hoping to use this to get closer to the level of content that I want to have for the first drafts of the lesson. This class is going to be about learning to program in Perl and Python, which are two programming languages. And the class, it assumes that you know how to use a spreadsheet or otherwise are comfortable with lightly complex things to do on a computer, but you don't have any prior programming experience. And I'm hoping to get you up to the level where you can actually write moderately complex software. I eventually will have a blackboard over here, and I'll be using that to help illustrate some concepts. But in this early lesson, we're going to start with metaphors. Because programming it's an activity which doesn't come naturally to humans. We will be using metaphors to help us approach it. A good grounding metaphor is something that you'll be looking for throughout your entire time as a programmer, from the beginning to much later on. You'll be working with metaphors as layers of abstraction, basically as stories that you tell yourself about what you're doing, so that you don't need to think about the very complex things that are actually going on inside a computer that are needed to do all of the details of everything that you want. Instead, you'll just be working with relatively simple notions of what's going on, just in the same way as if you're having a conversation with your neighbor, you probably don't want to be thinking about all of the neurons that are firing in his or her brain. You don't want to be thinking about all of the different features that are present in a human brain, if you even know about them. And this is one of the things about the metaphors that we use in programming. Often we don't really understand what's going on at the bottom level. So, without further ado, let's consider one of the first metaphors that you should be using to think about programming. You haven't done it before. You don't really know what it's about, but you've worked with software on computers. So, what is it like to program? Imagine that you have a box with a puzzle in it, a jigsaw puzzle. And like most people working with jigsaw puzzles, you want to assemble it from all of the pieces. So most of us have some experience doing this. But let's say that you need to explain how to assemble a jigsaw puzzle to somebody who's never done it before. And that somebody is very literal-minded, so they want instructions. So how would you do it? You might say something like, I'm going to dump all the pieces of the jigsaw puzzle on the table and try and find pieces that look like each other. And I'll try and put them together and see if they fit. And if they do, you have a larger piece. And that piece replaces the two smaller pieces that used to be in the pile. So that's great. That's a start. But it's not all there is to putting together a jigsaw puzzle. And it might not be precise enough for this very literal-minded person that we're giving instructions to. So, I ask you as an exercise how you would do this from the point of view of, or at least at the level of detail, where you're saying something like, I'm going to do this physical action, pour a box onto a table, start to sort the pieces this way before I even start looking at them, pick up one piece, pick up another piece, and do this to the two pieces, or even organize the pieces based on this principle. And the more organized you are, the more precise you are in describing this task, the closer you are to programming. So, having given you that assignment, let's talk a little bit more about the other metaphor that we're going to be using to begin to approach programming. And that's of a bunch of people in an office that are working together to, say, process driver's license applications. Now, you could have every person doing the exact same thing, but let's say that that in this office, you know that if you can give people a much smaller task and then have them hand off stuff to another person when they're done with it, you can achieve much greater efficiency. But you actually have to write the instructions for each person in order to do this task. So writing those instructions, that again is like programming, because programming, it's basically about giving instructions. There are some other parts of programming where you have to worry about other things. So in this office, you might say, this person, perhaps Bob, will initially look over the form and figure out, they'll look over the form and make sure that the person has actually filled out every bit in the form that's necessary. And if the form is filled out correctly, then Bob will hand it to Janet, who will then take it to some future stage of processing. If the form is not filled out correctly, then Bob will hand it to Jake, who will then go back and tell the user exactly what wasn't filled out correctly. Now, we have 3 sets of instructions that we need to write for this: Bob, Janet, and Jake. We're basically the initial looking over the form, the reporting to the user if the form isn't filled out correctly, and probably what went wrong, how they can correct it, and then the instructions for how we handle forms that are filled out correctly. And this type of organization of the instructions that are needed to do the whole task into separate subtasks, this helps us not need to think about a gigantic set of instructions in one piece. Now, maybe one programmer is writing all of this, but often programmers will divide up a larger task into several smaller tasks and assign different people to look at different parts of the program. In fact, sometimes the program itself will be divided up into components. But the important lesson that you can get from this is that many of the same principles of programming are principles that are used for any type of organization. Logistics is a huge part of programming. Being organized is a huge. It's an important thing that you need to be able to do if you're programming. Figuring out what went wrong when something goes wrong. It's another big part of programming. And these skills they're partly general. If you're really good at them in other domains, then hopefully you'll be good at them in programming. And if you happen to be good at them in programming, you might be able to use them to a certain extent in other domains. So I'm going to leave you with these two metaphors. If you can think about the jigsaw puzzle problem and just start to think about how you would really organize solving of a jigsaw puzzle, and be as clever as you can in really solving the problem efficiently, because we don't generally just pick up two random pieces when we're solving a jigsaw puzzle. Usually, if we've solved a few and if we really enjoy solving them, we actually get better at them. We develop tricks. We might decide to group things by color, group all the edges together, maybe look at the box to see what it's supposed to look like, and then start to look for features which we're going to have a fun time assembling. There are all sorts of tricks that we use for jigsaw puzzles. Try and figure out a way to describe them all, and to describe all of the components of how you would solve a real jigsaw puzzle, and make a good set of instructions. If you want to divide it up into things that different people would do, dividing into subtasks, go for it. If not, that's fine. Just start to think about the problem in this way, and you'll be taking your first steps towards thinking as a programmer. And as noted, this is just a first draft of the very first lesson that I'll be offering. I'm hoping to have better video quality in the future, since right now I'm actually recording on my tablet. And of course I'll be getting the ums out and getting smoother at offering this presentation. I'm more used to offering in-person classes where I'm looking at real people, working with them with computers. But bringing this to YouTube will hopefully help me tighten my teaching methods, and I think it'll just be useful for people on the internet to have yet another source of potential programming teachers that they can use. Although I guess teacher is a little bit of a misnomer, since I'm not actually offering the interactive teaching in this format. But in any case, comments are welcome. Please understand this is a first draft, and that the video quality is definitely not what it will be. And there we go. So